So remember that last lesson, I had said there were 3 rules to working with powers: the multiplication rule, the division rule, and the power of the power rule. Now, I don't know if you noticed, but last time we did multiplication and division, and then that was the end of the lesson. We were done. That's because I saved power of a power for its own lesson. So this is lesson 10 in Unit 1, the power of a power rule. So inside the power of a power rule, we're going to look at 3 different cases. We're calling them 3 different rules, but they're really just applications of the same rule, and they all come from the same foundation, which is how an exponent works, which is what we looked at a little bit yesterday as well. Last lesson. So in the rule, we have... Remember, we write this out algebraically first. We give you the general case. So a to the n raised to the power of m, in this case you see it's an exponent of an exponent, becomes a to the n times m. So now we're multiplying the exponents together. Remember, in the multiplication rule, we added the exponents. In the power of a power rule, we multiply the exponents. And let's take a little look at why that works. So, if I have 2 to the exponent 2 raised to the exponent 3, and an exponent is a repeated multiplication, so it tells us how many times we're going to multiply the base together. So what's the base in this case? Well, the base in this case is 2 to the exponent 2. So I have 2 to the exponent 2 times 2 to the exponent 2 times 2 to the exponent 2. That's what the exponent 3 is telling me. So now we can take this a step further. We can say this is actually 2 times 2, which is that exponent. And this becomes 2 times 2. And this one becomes 2 times 2. And when we multiply all those together, that's what exponents really are. It's repeated multiplication. And so I end up getting 2 to the exponent 6, which is the same as 2 to the exponent 3. 2 times 3 from the rule. So that's the basis of the rule. Let's look at some of these special cases. When we have an exponent and there's multiple bases within the brackets, remember, an exponent applies to everything inside the brackets. That doesn't change whether it's fractions, whether it's rational numbers, whether it's multiple operations. The exponent applies to whatever's inside that bracket. So when you have this exponent here, it applies to both of your bases. So what you're going to get is a to the n times p, all multiplied by b to the m times p. And then the other case is if we're actually dividing these bases inside the brackets and then raising them to a power. Hint, hint, just like rational numbers, except that now instead of a whole number, we have a power. And you're going to have to apply to the numerator and the denominator. You're going to get a to the n times p over b to the m times p. Just like that. All right, let's give it a try. First, 2 to the 3 raised to the power of 2. This might look pretty familiar. The rule tells me I'm going to multiply the 3 times 2 together and get 2 to the 6. Let's check that using the long way quickly. So this is 2 to the 3 times 2 to the 3, which becomes... That's one of our bases. We're multiplying it by another of our bases. And of course, that means we have 2 to the exponent 6. Yes! We win. It works out. Let's look at the next one. Oh, so now we're going to combine some of the rules from the last lesson. That's why I like to take this one as a separate lesson, because it lets us add those levels of complexity. So let's look at our numerator. X to the 3 raised to the power of 4 is going to give us x to the power of 12. I'm going to erase that. I don't need those brackets. x to the power of 12. 3 times 4 is 12. Okay. On the bottom, the denominator is x to the power of 2 times 3, which is 6. And then we do x to the 12 minus 6. Remember, numerator exponent minus denominator exponent. I'm going to get x to the exponent 6. Can I do this the long way? Yes. Let's try it. This is going to take a little bit. Bear with me. It will make sense. So what I have is x to the exponent 3 times x to the exponent 3, x to the exponent 3 times x to the exponent 3, all over x to the 2 times x to the 2 times x to the 2. Okay? So 1, 2, 3, 4, 5, 6, I need more space, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can't count today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. I've got 12. We're good. And then on the bottom, I'm going to have, there's my first 2. There's my second 2. There's my third 2. Let's do all our cancellation. 1 on top and the bottom, top and bottom, top and bottom, top and bottom. Right, so then I have my answer right here is x to the 6. Ta-da! So remember, if you can't remember the rule, you can always figure it out just by demonstrating that you understand what an exponent really is. Okay. Now it gets more fun. Here's an area where a lot of students get tripped up. What happens when you actually have an integer as a base inside that bracket? So when you have an integer as a base inside the bracket, you have to remember the exponent applies to it too. And that integer has an exponent on it even if it's not there. So in this case, I'm going to say we have a secret exponent 1. Okay? Don't forget those little hidden exponents. So in this case, we're going to have 4 to the 1 times 2 times z to the 4 times 2. This 2 has to apply to everything inside the bracket. Okay? Everything inside the bracket has to be affected by that too. So in this case, 4 times 1 times 2 is 4 squared, z to the 8. 4 squared is 16, z to the 8. There's the final answer. So be really careful when you run into those types of questions. Now, notice that when we do these types of questions, we don't have plus or minus anything inside the brackets. We're not working with multiple terms inside the brackets. We're only working with single terms. That's also really important. You will not be working with multiple terms being affected by exponents until you get to grade 10. So if you have pluses and minuses inside the brackets, it's an indicator that you need to simplify the bracket to a single term before you apply your exponents in this course. Let's look at example 4. And here's another case where you're going to be treating that integer base just like you would a variable. This exponent applies to both 3 to the exponent 2 and v to the exponent 6. And I'm going to get 3 to the exponent 4, that's 2 times 2. V to the exponent 12, 6 times 2. And 3 to the exponent 4 is 81. So this is 81 V12. And that's your final answer. Please do not forget to apply the exponents to your whole number bases inside the brackets. One last question for us to try here. We're going to do a little substitution. Remember I said when we're substituting, we always want to substitute into the brackets. In this case, let's simplify as much as we possibly can before we actually do our substitutions. So let's leave the variables in there and do as much simplification as possible. So let's start. We've got this here, so that's going to be x to the 15. Remember, it's the power of a power rule, so it multiplies. Y, 4 times 4 is 16. Okay, on the bottom, x 12. Y, 2 times 7 is 14. Okay, be very careful that you don't add those. That's a mistake that a lot of students make. They get rushing and they add them together instead of multiplying them. Now we're going to use our division rule. Remember, the division rule means that when you're dividing the same base, you can subtract the exponents. So I get x 15 minus 12, y to the 16 minus 14, x to the 3, y to the 2. Now, let's pull our substitution in. So that's going to be x is negative 2. So when I substitute, I'm actually going to write them in brackets like this and then apply the exponent. If you don't put the brackets in there, the negative doesn't get applied correctly. So you have to put the brackets, or you're going to mistakenly follow the wrong rules. Y equals 3, so 3 to the exponent 2. That's going to be negative 8 times 9. That's going to be negative 72 is your final answer.